Welcome to the Australian Primary Science Framework. This is an experiment for grade 3 and 4 students, and it comes out of the unit The Force to Move. So what we're trying to do is we're asking the question, will a heavier car travel further distance than a lighter car when the same force is applied? So to do this experiment, we've got our gravity launcher here. We've got a little blue toy car, and what we're going to do, we're going to measure the distance by placing red and blue dots. So the red dots will represent the heavier car and the blue dots will represent the lighter car. And so what we're going to do is, to make the car heavier, I've got a stack of blue tack here, and I'm just going to put that on the roof, and that will make the car heavier. Now, in addition to answering the question, which we're really trying to do through observation, we're also trying to teach the students about the idea of a fair test. So that's why I've got one car, so that I'm using the same car all the time. On my little gravity launcher here, I've got a small line marked, and that's where I'm going to launch the car from every time, so, as you can see. And because at this level, in trying to organise a fair test, we would do the experiment a number of times, students haven't been exposed to the idea of a mean or an average. So we'll put the dots where the car finishes and get a graphical view of the differences, so that the students will be able to make that observation, and we're making the observation much clearer by doing that. And they'll be able to answer the question whether the heavier car travels further than the lighter car. So we'll do the experiment. So we'll start off with the lighter car. So we'll use the blue dots for the lighter car. And what I'll do is I'll do it 5 times. And we'll put the dots down. So we'll start the first one. So here I've got my car, and I'm lining the front wheel up with the line, and I'll launch that. And so you can see the first dot in terms of how far that car has travelled. So that's the first one. So I'll now do that again for a second time. And you can see we're getting reasonably consistent results out of those two. In fact, that one is just about right on. So we've got a good surface and a good experimental setup here. There's the fourth one. So those dots are quite consistent, and we'll do a fifth one. So we can see hardly any difference, at the most just a couple of centimetres. So now what I'm going to do is that, in the idea of keeping it as a fair test, use the same car, and the only thing I'm going to change is the weight of the car. And so this is with the blue tack here, so I'll just stick that on there, and we'll now use the red dots to measure the distance of the heavier car. So again, same thing, we'll line the wheels up exactly the way in which we did before, and let's see what happens. So that is very, very close to the blue dots there, but we need to do a few more trials to see what's going on. So second trial. And there we are. So interesting to think what is happening here. Third trial. trial, and again we're getting very even, very nicely clustered results. And the last one, so what we've got here, if we were doing this experiment with older students, we'd be measuring the distance and we'd be calculating the mean, but we can't do that with grade 3, grade 4 students. So these dots give us a nice visual picture, and the question is, does the heavier car travel further than the lighter car? So that is, with the red dots, have they travelled further? And it would seem from here that that's not the case. And of course that's exactly what we would expect, that the mass of the vehicle, or the weight of the vehicle, has no impact in this experiment. Now, first of all, we know that energy is a product of the vehicle's mass and its speed. So if I increase the mass, I increase the energy, and if I increase the energy, you would expect the vehicle to travel further. But at the same time, we've got the force of friction, which is slowing down the vehicle. And the force of friction is also dependent upon the mass or the weight of the vehicle. And in fact, the greater the mass, the greater the friction. And if you think about, say, getting a small piece of wood and putting it on sandpaper, just gently moving it across the sandpaper, it's reasonably easy to do. But if you push down on that piece of wood, you're increasing the mass of it, and you're increasing the friction, and it's quite hard to move. So whilst the increased mass would make it go further, the increased friction as a result of the mass would slow the car down, and so what we get is that the mass has no appreciable effect on here. So with our students, we're not interested in the explanation. Grade 3 and 4 students aren't going to be able to make that sort of logical, mathematical explanation, but what we want them to do is to observe and get the idea of a fair test so that we could make accurate observations of the world around us. And so if our children can walk away from this experiment having clearly observed the distance travelled and seen clearly that the mass has no effect, well then I think we've done a great job with the kids. Thank you.